Today, I want to help you with your Arduino projects. This is my talking hat. It was designed to flash LEDs, display words, detect sounds, have multiple functions, and really be the ultimate party trick. So, when I started this project, I really had no idea how to take on more advanced Arduino projects. There weren't many resources online, so the reason I'm making this video is to help you with your more advanced projects. So before I give you all of the tips to make you succeed, let's go back to the beginning of my talking hat project. Okay, I just finished my first schematic for a printed circuit board, or PCB. I have the files ready to send over to PCBGOGO. I'm super excited because I know they have a reputation for high quality boards. I traced out how the pins will connect, and I even put the channel logo on it. Today's sponsor, PCBGOGO, is a 5-year-old company that already is at the cutting edge of PCB production. They offer quick-turn PCB fabrication and turnkey PCB assembly from prototype to mass production. PCBGOGO is one of the leading Chinese PCB manufacturers and is a great option for projects big and small. Alright, I finally have all of the components shipped. Alright, we got it. So here's the full Nano, and then it has the header pins all attached. Now there is another one that we could put up here, but since I'm not using that in this project, I'm not going to. And I have some permanent damage on the breadboard. So if you're doing this and putting it on the breadboard, make sure your soldering iron doesn't hit and make marks. Okay, so right now I have a mount for the PCB and the LCD screen printing. I just designed it, and yesterday I finished soldering the Nano, and while this is printing I'm going to solder the Nano onto the PCB as well as the resistors and the buttons. Print just finished up, so today I'm going to finish cleaning it up and taking off the supports, and then finish up soldering everything so that tomorrow I can start writing the code. Okay, so this test did not really go as planned. First of all, there are holes in here, so the LED can slide in, and then the leads go through the holes. However, it's not big enough for the LED to go down. Also, I realized I don't really need these supports or the stomachs, because when I put this on in the back, the LCD screen is going to go through here, and then I'm going to rely on the connection from the LEDs to the holes down here. Okay, so I caught this print about halfway through, and I realized these pieces aren't one body. So in the design I made it so small that it didn't recognize that it was supposed to connect it. So I'm gonna have to go back and then change the design a little bit. Okay, this print is 23 minutes in and it already looks way better than this. I changed the holes so they're squares so I don't have many fibers bridging across. It looks a lot better. Okay, so here's the remnants from the last print. I stopped it halfway and these didn't bridge over. So in my next test, I printed it again, and this time I connected it on the bottom, so it's still kind of open, but it's a lot more solid now. And one more thing I forgot to do was actually measure out where the LCD is going to be on the back of this. So I put it right here and put this on top, which is very hard to show on the camera, but basically it should line up. So I redesigned it one more time, and I added little places at the four corners to put the M3 screws through the LCD. So I think I'm finally done with CAD, but we'll see how it turns out. Okay, I just finished and I got the final 3D printed part. Next I'm going to put all the LEDs in place and put the LCD in place, and then I'll finish soldering everything on. Alright, this is my first attempt at coding this Arduino Nano. So the first issue I had was going to Tools and then Processor, and I actually have to use the old bootloader. Unfortunately, with the newer one, I could not establish connection, so the old bootloader works just fine. So for this code, I just wanted to test out the buttons that I have soldered. So when I go to the serial monitor here, you can see that it shows a string of ones. So let me zoom in here. And then when I press the button, the ones change. And they go in order. So that means we have input. Finally. Now, I'm finally gonna finish soldering this thing so I can get started on writing the full code. And right about here is where a lot of things started to go downhill. I realized that when I plugged in the wiring in the PCB software, I wasn't really thinking about how all the components would fit together in real life. So one of the holes blocked something that I needed to code the Arduino with. So when you're making your PCBs, make sure to realize that it's going to be something physical in real life. Next, I realized that the LCD screen, the one that prints out words, was not working. When I saw the I2C communication on the back, all I was looking at were the 4 pins used to control it, rather than the usual 16 it takes. What I did not know is that they had to plug into specific pins on the Arduino. I should have researched more about the component, rather than just randomly guessing in the design. As you can see, on this diagram, some pins have an extra label for communication. I2C is a type of communication, which I found out during this project, and I didn't know that while I was designing the PCB. So make sure that you check your components to make sure they match with the correct pin. I tried to work around this by switching out the LED pins and the pins I needed to use by using wires. This worked to recover the LED functionality, but for some reason it didn't recognize the I2C device. This almost made me give up on the project, but I made a decision that I was not going to stop until I was happy with the result. Thankfully, I noticed the tracing, or the lines on the PCB board, were telling a different story than the schematic I had on my computer. I quickly rushed to the soldering iron, fixed the wiring, and I got the LCD screen to work. I also realized if I ever need to adjust the potentiometer to change the contrast on the LCD screen, all I have to do is unscrew it. So after a little perseverance and some creative soldering, I managed to get the hardware working. Now, it's time to code. Okay, I just uploaded all of the code to the Arduino Nano. I was pretty efficient and managed to fill up about 35% of the Arduino storage. I filled it with 4 functions, and if I ever want to add more, I can with ease. Now there's only one thing left to do. Put it in the hat. Finally finished. Now I can peel this off, and it's time for the first test. Alright, here we go with one of the first tests. So, plug this into the back. Awesome. So far, so good. So, I have a bunch of functions on here. Let me know in the comments section below if you want to see all of them. For now, I'll just show you the first one, which has some, there we go, some songs built in. Alright, it works, and now it goes into another function where it just goes on loop, showing all the different patterns you can do with the LED lights. So again, if you want to see all of the functions, let me know in the comments down below and I'll make another video on that. Once again, here are all the tips from this video. Number 1, research your components before you do anything permanent. I didn't understand how to use the LCD screen with I2C communication, which gave me a lot of problems down the road. I should have researched that more. Number 2, if you can't make something perfect, make it adjustable. I did this by attaching my LCD display to the 3D printed part by using screws. That way, if I ever needed access to something inside, all I have to do is unscrew it. Number 3, stay persistent. There were so many times in this project where I thought, man, this isn't gonna work out and I don't think I have enough time to finish. But it turns out that if you keep going and you decide you're going to finish your project, you will. So keep pressing forward, and usually the answer is right around the corner. Use what you know will work and learn what you don't. PCBGOGO is a great place to get high quality boards every time. So use them if you want guaranteed quality in your PCBs. And if you don't know how a component works, look online. There are plenty of resources for you to choose from. And if you just look up a model number or any kind of text on a component, you are probably going to find something. There were a lot of times during this project where I thought I couldn't continue. But when you decide that you are never going to quit and you will keep working towards your goal, then you will succeed. So thank you so much for watching, and remember this during your next project. Thank you to PCBGOGO, and please check out the links in the description to head over to their site. I will see you next time.